Okay, so the last trend that we'll discuss here is known as ionization energy. We'll abbreviate that capital I, capital E. And again, remember this excludes the noble gases in this discussion. So ionization energy is kind of the opposite concept from electronegativity, but you'll find their trend is actually the same. So ionization energy is the energy required to remove an electron from an atom. So if you remove an electron from an atom, you make it positive. So this is a measure of how easy or how difficult it is to make an atom positive, basically. So let's think about sodium. Sodium likes to have a positive 1 charge. So that means it likes to give away an electron. So if it likes to give away an electron, it's not going to require much energy to remove that electron. Fluorine, on the other hand, likes to have a negative charge. So it likes to gain electrons, not give them away. So if it likes to gain electrons and not give them away, it would require a lot of energy to pull that electron away. Okay? So we can make a note, atoms that form cations have lower ionization energies than atoms that form anions. And so that kind of makes sense. If you're going to form a cation, if you want to have a positive charge, it would take less work to remove that electron from you. You kind of want to give it away. So let's look at the trend. So ionization energy increases as you move right and up the periodic table. Okay. So let's look at an example of that for each of these. So let's look at sodium and potassium. So sodium has 3 energy levels. Potassium has 4 energy levels. Okay, so they each have 1 electron in the outer energy level there. Okay, so if we think about shielding here, okay, so I could say, so this is sodium, this is potassium. Okay, so potassium's electron is more shielded from the nucleus. Okay, so if it's more shielded from the nucleus, that means the nucleus isn't holding it as tight. Okay, so potassium's electron is more shielded from the nucleus and can therefore be removed more easily. Okay, so if it can be removed more easily, that means it requires less energy to remove it. Okay, so the farther an electron is away from the nucleus, the more shielded it is, the easier it is to remove it. Okay, so we can say easier to remove equals lower ionization energy. Okay, so that explains why sodium has a higher ionization energy. It takes more energy to remove that electron because the nucleus is holding it tighter. Okay, the effective nuclear charge for sodium is greater here because it is less shielded. Okay, so then let's look at an example of, let's just say, sulfur and chlorine. Okay, so they each have 3 energy levels, but sulfur's nucleus has a plus 16 charge, chlorine's nucleus has a plus 17 charge. Okay, and they each want to put electrons in that outer energy level. Okay, so shielding here is equal. Okay, so they each want to put electrons in the outer energy level, but we're discussing ionization energy, which is the amount of energy needed to remove an electron. Okay, so think about here, if we have an electron out here, we know both of these will have higher ionization energies than will sodium or potassium, because these 2 atoms down here don't want to lose their electrons, whereas sodium and potassium do. So if you think about, the only difference in these 2 atoms really now is their nuclear charge, their Z. because their shielding is approximately the same. So chlorine, so we'll just say chlorine's electron would require more energy to remove because it has a greater nuclear charge. So that plus 17 can more tightly hold an electron than that plus 16 can. So those are explanations as to why ionization energy increases up and to the right. This one can be tricky because we think about the trend as which way it increases, but then we explain it in terms of which is easier to remove an electron from. So don't get that confused in your mind. Be sure you think about which has a higher ionization energy, which means it's more difficult to remove an electron from. Let's look at a few examples. Let's look at phosphorus or sulfur. Then let's look at bromine or iodine. So higher ionization energy. And then why? So phosphorus or sulfur, the correct answer is sulfur. Okay, so shielding is approximately equal, but sulfur has a greater nuclear charge, which can better hold the electron. So if it can better hold the electron, that means it's harder to pull the electron away. It requires more energy to remove that electron. So bromine versus iodine, correct answer is bromine. So bromine's nucleus is less shielded, which means it can more tightly hold the electron. So if it can more tightly hold the electron, that means it's difficult to pull the electron away, and therefore has a higher ionization energy.